Hello everyone, I'd like to welcome you all in my YouTube channel, that is NIROJNA'S tutorial. Again, myself NIROJ, and today I've come with new video, and my topic of the video is matrices. Wow. So basically this topic is only for those students who are appearing for ICSE this year, and I know some topics are in class 11 also, so I will not touch that part which is in the class 11. Alright, so only for ICSE appearing students. Alright, so today we'll start matrices, and I'll talk about matrices from top to bottom. Alright, first thing is, what is a matrix? What is a matrix? A matrix is a rectangular arrangement of numbers. So it is very simple, in the form of rows and columns. So a rectangular matrix is just a rectangular arrangement of numbers in the form of rows and columns. Like we have different types of matrices, so later on we'll talk about that. For example, if we write the numbers in box and write, say, A, B, C, D, there are 4 elements, 4 numbers, and they are arranged in rows and columns. So there are 2 rows and 2 columns. So this is called a matrix. Alright, so let's talk about order of a matrix. Order of a matrix. Order is very simple. Order is none other than number of rows and number of columns in the matrix. For example, in this matrix, like A, B, C, D, number of rows is 2, and number of columns is 2. So if you write this order, then here you will write 2 by 2, that is 2 number of rows and 2 number of columns. So this is only thing what the order of matrix gives us. Alright, so and if you multiply these two numbers, literally if you multiply these two numbers, that is number of rows and number of columns, you will get the total number of elements present in the matrix. Alright, third term is equal matrix. Equal matrices. So let us take 2 matrices, say A and B. They are equal if and only if there are 2 conditions, 1 and 2. 2 matrices, matrix whole is considered as or denoted by capital letter A, capital letters of the English alphabet, and the elements of the matrices can be denoted by the small letters like this, A, B, C, D. Okay, 2 matrices A and B can be equal, or if they are equal, then there are 2 conditions in under which these 2 matrices can be equal. First condition is their orders must be same or must be equal. That means both of these 2 matrices should have of same order, should be of same order. Number 2 is each corresponding elements must be equal. That means there are 2 conditions for 2 matrices to be equal. First one is their orders, which we have already understood here. So their orders must be equal. And number 2 is corresponding elements of the 2 matrices must be equal. For example, if matrix A is A, B, C, D, say A1, A2, A3 and A4 is the matrix A, and B1, B2, B3 and B4 is the matrix B. If they are equal, we can see their orders are 2 by 2 and 2 by 2. First part is Done, verified, their orders are equal. And second part is their corresponding elements. That means first element must be equal to first element. Similarly, second element must be equal to second element. Third element must be equal to third element. And fourth element must be equal to fourth element. That's it. So these are the order of matrix and equal matrix. So let's talk about type of matrix. Now let's talk about type of matrices. Alright, so there are 6 types of matrices.
Amazing!
So first is row matrix. Alright, so let's understand what is a row matrix. In row matrix we have only one row, but we can have more than 2 or 3 columns. Alright, for example, if I take 3 numbers 2, 3, 5, in this example we have only one row, but we have 3 columns. Alright, so order of this matrix becomes 1 by 3. Alright, I'll give you one more example. So if I take 5 numbers in row matrix, then let us take 5, 4, 3, 2, 1 and see there is only one row, but there are 5 columns. So its order becomes 1 by 5. That's it, it's easy. So let's go to next type, that is column matrix. In column matrix we have only one column, but this is like a vertical matrix. There is only one column, but it can have more than 2 rows. So let us take two elements in column matrix, right? So there are 2 rows, but only one column. Okay, it means that its order becomes 2 by 1. You can take some more example, like if I take 4 elements, 1, 2, 4, 1, 3, like this. There are how many rows? 1, 2, 3 and 4 rows, but only one column. So its order becomes 4 by 1. From these 2 examples, from these 2 types, I came to a conclusion. That conclusion is, if there is a row matrix, then its first part, that is first part of the order, always equals 1. And if it is a column matrix, then its second part of the order becomes 1. So if there is only order of matrix given to you in your examination and you have to identify whether it is a row matrix or column matrix, then just look at the first part. If the first part is 1 and the second part of the order is not equal to 1, then that is a row matrix. And similarly, if the second part of the order, that is second part, is 1, then the matrix is a column matrix. Alright? So let's go to square matrix. Square matrix. In a square matrix, the number of rows and number of columns are always equal. For example, if I take 4 elements, 1, 2, 5 and 6. So you can see number of row is 2 and number of column is also 2. That means its order is 2 by 2. And similarly, if you take a matrix of order 3 by 3, then you have 9 elements, 4, 2, 3, 4, 1, 5, 6, right? So there are 3 rows and 3 columns. So that's why its order is 3 by 3, excuse me. Now, if only order of the matrix is given to you and you have to identify which matrix is this, then just look at the order. If the order are of the same number, 2 by 2 or 3 by 3, you can consider it as a square matrix. Let's go to next matrix, that is rectangular matrix. In this matrix, the number of rows and number of columns are not equal. Like if I take 1, 2, 3, 4, 5, 6. In this matrix, number of row is 2 and number of column is 3. So these two, number of rows and number of columns are unequal. That's why it is a rectangular matrix. It can be of like this, 1, 2, 3, 4, 5, 6. That is, it has 3 rows and it has 2 columns. So it is a matrix of order 3 by 2, which is also a rectangular matrix. From this point, I again came to a conclusion. That conclusion is all the row matrices, that means row matrix also has unequal number of rows and columns, so they also fall in this category, that is rectangular matrix. Alright. Similarly, column matrix also have different number of rows and columns, so they also fall in the rectangular matrix category. Alright, so we can say all row matrix is a rectangular matrix, all column matrix is a rectangular matrix, but every rectangular matrix is not a column matrix or not a row matrix. Alright, after that, number 5 is null matrix or void matrix. We can tell it as a null matrix or void matrix or zero matrix. So it can be of any order. Null matrix or void matrix can be of any order. It can be a rectangular matrix, it can be a row matrix, it can be a square matrix, or it can be a column matrix. But every element of the matrix is 0, then these types of matrix are called null matrix. It is denoted by O. Alright. Next is number 6, which is important. That is called identity matrix. Alright. Identity matrix. We have to consider only a square matrix for identity matrix. Rectangular matrix or row matrix, column matrix cannot be an identity matrix. Only square matrix can be an identity matrix. For example, if I take an identity matrix of order 2 by 2 and of order 3 by 3, and I write 1 0 0 1, okay, that means these elements which falls on the leading diagonal all are 1 and the remaining elements are 0. They are called identity matrix and denoted by capital I. Alright. Similarly, for 3 by 3, if I write 1 1 1 and all remaining elements are 0, then this leading diagonal has all elements 1 and remaining all elements are 0. So this is also a identity matrix. So these are the types of matrices which we used to learn in our school and which we will implement in our sums.